Hello students, welcome to my YouTube channel Lekkala Lokam. Have you ever wondered why some numbers are called special numbers in mathematics? What do these numbers have in common? At first, they may look like ordinary numbers, but hidden inside them is one of the greatest mysteries in mathematics. These numbers are called prime numbers. Prime numbers are so special that mathematicians have been studying them for more than 2000 years. And even today, many secrets about prime numbers are still unsolved. In fact, prime numbers are called the building blocks of mathematics. In this video, we are going to learn what are prime numbers, what are composite numbers, the famous method to identify prime numbers, what are twin prime numbers, what are co-prime numbers, smallest and largest prime numbers, and many interesting facts. So watch carefully till the end because this topic is very important not only for school mathematics but also for higher studies. Let's begin. What are prime numbers? The numbers which have exactly two factors are called prime numbers. Those two factors are 1 and the number itself. For example, 2 has factors 1 and 2. 3 has factors 1 and 3. 5 has factors 1 and 5. 7 has factors 1 and 7. And 11 has factors 1 and 11. Since these all numbers have only two factors, they are called prime numbers. What are composite numbers? Numbers having more than two factors are called composite numbers. For example, 4 has factors 1, 2, 4. 6 has factors 1, 2, 3, 6. 8 has factors 1, 2, 4, 8. 9 has factors 1, 3, 9. 10 has factors 1, 2, 5, 10. These numbers are having more than two factors. So these numbers are called composite numbers. Look at this first 20 natural numbers. There are some prime numbers and some composite numbers in these numbers. As we discussed earlier, 2 is a prime number, 3 is a prime number, 4 is a composite number, 5 is a prime number, 6 is a composite number, 7 is a prime number, 8 is composite number, 9 is composite number, 10 is composite number, 11 is prime number, 12 is composite number, 13 is prime number, 14 is composite number, 15 is composite, 16 is composite, 17 is prime number, 18 is composite number, 19 is prime number, and 20 is composite number. And you can see 1 is left over. This is neither prime nor composite number because it has only one factor, that is 1. You can see the least prime number is 2 and the least composite number is 4. In all prime numbers, 2 is the only even number. Remaining all numbers are odd prime numbers. How to identify prime numbers easily? The study of prime numbers began in ancient civilizations. More than 2000 years ago, Greek mathematicians studied these mysterious numbers carefully. One famous Greek mathematician named Eratosthenese found a smart method to find prime numbers. Eratosthenes is a mathematician, geographer, astronomer, and scientist. He invented a brilliant method called the Sieve of Eratosthenes, which is still taught in schools today. The word sieve means filtering. Just like we separate stones from rice using a sieve, this method separates prime numbers from composite numbers. In this smart method, we can separate prime numbers quickly from other composite numbers. Let us learn the beautiful method sieve of Eratosthenes. To do this activity, we need to write 1 to 100 natural numbers in a table. From this table, we will remove all composite numbers and we will draw prime numbers. For doing that, we need to cross all composite numbers from the table. As you know, 1 is neither prime nor composite. That's why let us cross this number. And you also know that 2 is a prime number. It is a least prime number. Since 2 is a prime number, we need not cross this number. But all the multiples of 2 become composite number. That is why we need to cross all the multiples of 2 from the table. So you can see the multiples of 2 are 4, 6, 8, 10, 12, 14, 16, 18, 20. You can observe all the numbers in this column are multiples of 2. Also all the numbers in this column, this column, this column, and also in this column are the multiples of 2. Let us cross all the multiples of 2 in this way. Now the multiples of 2, which are composite numbers, removed from the table. Now let us move to the next prime number 3. In the similar way, we need to cross all the multiples of 3 from the table. For that, I have already taken the multiples of 3 in the list. So we can see easily the multiples of 3 here and we can cross the numbers in the table. The multiples of 3 are 6, 9, 6 is already crossed, we need to cross 9, 12 is already crossed, we need to cross 15, and 18 is crossed. The next number is 21, next number is 24, already crossed, 27, 30, 33, 36, 39, 42, 45, 48, 51, 54, 57, 60, 63, 66, 69, 72, 75, 78, 81, 84, 87, 90, 93, 96 and 99. So the multiples of 3, which are also composite numbers, are also removed from the table. Let us follow the same procedure for remaining prime numbers. The next prime number in the table is 5. Since 5 is a prime number, we cannot cancel 5, but we need to cancel all the multiples of 5 from the table. That is very easy. All the multiples of 5 are 15, 25, 35, 45, 85, 95, and the numbers containing 0 in the units place also multiples of 5. That's why we need to cancel all the numbers in this column and this column. All the numbers in this column are already cancelled. The next prime number in the table is 7. Since 7 is a prime number, we cannot cancel it, but all the multiples of 7 we need to cancel. These are the multiples of 7. Let us cancel all the multiples. 14 is already cancelled, 21 cancelled, 35 is cancelled, 42 is already cancelled, 49 we need to cancel this number 49. And the next number is 56, already cancelled, 63 is already cancelled, 70 cancelled, 77 we need to cancel the next number 77, 84 is already cancelled, 91 we need to cancel 91, and 98 is already cancelled. The next prime number in the table is 11 and we need to cancel all the multiples of 11 from the table. Those are 22, 33, 44, 55, 66, 77, 88 and 99. All the multiples of 11 are already cancelled. Let us move to the next prime number, that is 13. We need to cross all the multiples of 13 from the table. These are the multiples of 13. First number is 26. 26 is already cancelled. 39 is cancelled. 52 is cancelled. 65 also cancelled. 78 is already cancelled. And the next number is 91. Even also cancelled. The next prime number in the table is 17. Let us cross all the multiples of 17. Those are 34 is already cancelled. The next number is 51. 51 is already cancelled. 68 also cancelled, and 85. 85 also cancelled. All the multiples of 17 are already cancelled. The next prime number in the table is 19. These are the multiples of 19. Let us cross the multiples of 90. 38 is already cancelled. 57 is cancelled. 76 is already cancelled. 95 also already cancelled. The next prime number in the table is 23. These are the multiples of 23. 23 is prime number. 46 already cancelled. 69 is already cancelled. 92 is also already cancelled. Next prime number in the table is 29. The multiples of 29 are 58 and 87. 58 is already cancelled. 87 is also already cancelled. The next prime number in the table is 31. The multiples of 31 are 62 and 90. 62 is already cancelled and 93 is already cancelled. And the next prime number you can see in the table is 37. The multiples of 37 are, only one multiple is there, that is 74. 74 is already cancelled. The next prime number is 41. The only multiple of 41 is 82. 82 is already cancelled in the table. The next prime number is 43. The multiple of 43 is only 86. 86 also cancelled in the table. And the next prime number in the table is 47. The only multiple of 47 is 94. 94 is already cancelled. And the next prime number is 53. The multiple of 53 is 106. That is out of the box. That's why this process completed for all the natural numbers from 1 to 100. Now you can see the final prime numbers from the table are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, finally it is 97. You can see there are 25 prime numbers in the first 100 natural numbers. This is the method of sieve of Eratosthenese. This method is fast, easy and systematic. It is useful for large range of numbers also. Modern mathematicians also use similar ideas with powerful computer algorithms. You can see there are 25 prime numbers between 1 and 100. If you continue this method for 100 to 200 numbers, we can find that there are 21 prime numbers between 100 and 200. There are 16 prime numbers between 200 and 300. Also, there are 16 prime numbers between 300 and 400. Between 400 and 500, there are 17 prime numbers. Similarly, we can find the number of prime numbers between the ranges 600 to 700, that is 16 prime numbers, 700 to 800, that is 14 prime numbers, 800 to 900, 15 prime numbers, 900 to 1000, 14 prime numbers. In the first 1000 natural numbers, there are 168 prime numbers. Is there largest prime number? It's an interesting question. The answer is no. Prime numbers go on forever. Here is the small mystery about prime numbers. Can you predict the next prime number easily? Sometimes prime numbers appear close together, but sometimes far apart. There is no simple pattern in the prime numbers. That is why prime numbers fascinated great mathematicians throughout history. He is a Greek mathematician, lived in 300 BC. He proved that prime numbers never end. That means no matter how many prime numbers we discover, there is always another bigger prime number waiting to be found. Modern prime numbers discovery. Even today, mathematicians and computer scientists use powerful computers to search for gigantic prime numbers. The largest prime number discovered so far is 2 raised to the power 136,279,800 841 minus 1. This prime number was discovered in the year 2024 and it has 41,024,320 digits. Imagine writing a number so large that it fills thousands of pages. These extremely large prime numbers are called Mersenne primes. Now let us discuss what are twin prime numbers. Two prime numbers having a difference of 2 are called twin prime numbers. For example, 3, 5, the difference between these two numbers is 2. That's why these two prime numbers are called coprimes. Similarly, 5, 7, 11, 13, 17, 19, 29, 31, 41, 43, 59, 61, 71, 73 are called twin primes. The largest pair of twin primes in the first 1000 natural numbers is 881 and 883. Mathematicians still do not know whether infinite twin primes exist. This is one of the famous unsolved problems in mathematics. Let us discuss what are coprime numbers. Two numbers having no common factor other than 1 are called coprimes. For example, if you see the factors of 16, 1, 2, 4, 8, 16 are present. If you see the factors of 25, 1, 5, 25 are present. You can see they have no common factor except 1. So they are called coprime numbers. The HCF of coprimes. The highest common factor of coprimes is 1. And you have to understand coprimes need not be prime numbers. Prime numbers may look simple, but they hide many mysteries. Even today, mathematicians around the world continue researching prime numbers. So practice identifying prime numbers and try using the Sieve method yourself. If you enjoy the video, like my video, share my video and subscribe to my YouTube channel and support my channel for more interesting mathematics videos. Thank you students. See you in the next video. Have a great day.